Today we're going to be talking about multiplying binomials. Binomial, if you remember, means two terms. So we're talking about something with two terms, like 2x plus 3, being multiplied by something else with two terms, x plus 7. Okay? So each of these have two terms, 1, 2, 1, 2. Alright? And we want to multiply them. Unlike yesterday, yesterday we just had one thing that we needed to distribute over a polynomial. What's interesting about this is that we actually have two things that we need to distribute. It's still the distributive property, okay? And so don't think it's anything different from what we're doing yesterday. It's just instead of having to multiply one thing, we're going to have to multiply two things. We still end up with very similar answers. It's going to be a matter of keeping yourself organized. Where students usually go wrong in these kind of problems is they forget to multiply something. And so any way that you can keep yourself ultra organized and make sure that you get everything multiplied by each other that needs to be multiplied by each other is great. I'm going to show you two methods that I know, that I've seen. I've seen several. These are my two favorite. It's just a matter of finding the one that works for you. So you can pick whichever you choose. It does not matter to me which method you prefer, but find the method that works for you and stick with it. It is still all based off of the distributive property. And so probably the biggest and best known one that is based off of the distributive property is called FOIL. And what a funny thing to call something. But it's called FOIL, the FOIL method. I learned the FOIL method back eons ago when I was in school. This has been around for a long time. But the FOIL method is based on the idea of trying to remember what all needs to be multiplied by each other. We've got four terms up here, and somehow we've got to get all four of these terms multiplied by each other and not multiply something too many times and not forget to multiply something. And so this is just a little, an acronym, is that the correct word for it? For remembering what needs to be multiplied by each other. For first, outer, inner, last. First, outer, inner, last. Meaning that I need to multiply the first terms times each other. I need to multiply the outer terms times each other. I need to multiply the inner terms times each other. And I need to multiply the last terms times each other. You can draw this a bunch of different ways. I've seen people do it as like, here's some eyebrows, and here's a nose, and here's a smiley face. All kinds of different things to try and remember this. But we generally refer to it as FOIL. So if you hear your teacher next to you say, use the FOIL method, this is what they're talking about. So let's see how that works. I just need to multiply. So first I'm going to do my first terms. 2x times x. 2 times 1 is going to give me 2. And then x to the first times x to the first, 1 plus 1 is going to be 2. So I get 2x squared. Now I've got to do my outer terms. 2x times 7. So 2 times 7 is going to be positive 14. And x times, well, there is no x, so it's just going to stay x. Now I've got to do my inner terms, these two inner ones. So 3 times x. 3 times 1 is 3, and then there's no other x, so it's just going to stay together. And then our last terms. 3 times 7 is positive 21. So first, outer, inner, last. One thing that you want to watch for when multiplying binomials, though, is that these two inner terms here, when you follow FOIL, notice that they're like terms, 14x and 3x. Because they are like terms, we do have to simplify and put them together. We can't leave it like this. So 2x squared is not going to change, but 14x plus 3x is going to become 17x. And then we also still have plus 21 out here. The interesting thing is, after you've done a ton of these problems, what you realize is that happens every time. And so you're just getting into this pattern of do the FOIL, multiply it out, and get the four terms, and then check your middle two terms so that you can simplify them and put them together. So first, outer, inner, last. Another example of the FOIL method. Let's try one more example. 5x minus 3 and 2x plus 8. So first, outer, inner, last. So I'm going to need to multiply my first terms. 5 times 2 is 10. and x times x is going to be x squared. Outer. Alright, so I've got 5 times 8, which is positive 40, and then x times, there is no other x, so it's just going to stay x. Now we've got to do our inner. Alright, so this is a negative 3. Watch out for negatives. Negative 3 times positive 2 is negative 6, and then the x, there is no other x, so it's just going to stay x. And then our last, again, negative 3 times 8 is negative 24. Alright, so first, outer, inner, last. So here's his big smiley face. This is his nose. We've got these eyebrows going on up here. There you go. So we make a little smiley face. First, outer, inner, last. The other thing is you're taking the first one, multiplying it by both of them, taking the second one, multiplying by both of them. It's just the distributive property. However, we're not done. We do need to simplify and put our two terms together here. So we end up with 2x squared. 40 minus 6 is going to be positive 34x, and then we still have the minus 24. So it's a two-step process. After you do all the multiplication, you do have to add those two middle terms together. This is one method. Another method, it does the exact same thing, people. We are still multiplying a binomial times a binomial. It's just a different way to organize it to make sure you don't forget to multiply something. Because again, the easy thing here is to get into this multiplying process, lose track of what you have and haven't multiplied, and just leave one out. Forget to say negative 3 times 2x, and then just give 10x squared plus 40x minus 24. So many students do that. They just forget to multiply something. And so we need some way to keep up with it, and that's where we come up with the box method. Some people call it a modeling method, but whichever way you want to word it, it involves a box. So let's say that we have a binomial, 3x plus 4. We want to multiply it by another binomial, 2x minus 1. All right. The idea with the box method is I'm going to draw a box, aptly named the box method. And we're going to put a little cross in our box, so we actually end up with 4 squares. And we're going to take each binomial and write it across the sides of the box. This is just 3x plus 4, and this is 2x minus 1. All right? And what this does is it gives you a visual so that it is impossible to forget to multiply something. Because if you fill in every box, then you've multiplied everything. If there's an empty box, you forgot to multiply something. So this just forces you to not forget to multiply something. But you do the same things. 2 times 3 is 6. X times x is x squared. 2 times 4 is 8. X, and there is no other x, so it's just x. Negative 1 times 3 is negative 3. There is no other x. And negative 1 times 4 is negative 4. Now the cool thing about the box method, just like with our other method, we always ended up multiplying these two middle terms. With the box method, the terms that we want to look and see if they add is always right here on the diagonal. These are the two terms that we want to see if they can add. And sure enough, we've got an x and an x, so they can. So when we write our final answer, we're going to end up with 6x squared, positive 8 minus 3 is going to be positive 5x, and then we have our minus 4. So this is our final answer. Let's do one more example with the box method just so we can see what it looks like. Alright, so 4x plus 2 and negative 3x plus 7. Draw in my box. Got a nice little box going on, so I've just got to write here 4x plus 2 and negative 3x plus 7. Alright, negative 3 times 4 is negative 12. Oh, I said negative 12 and I wrote negative 14. That's a problem. Alright, negative 12. X times x is x squared. Negative 3 times 2 is negative 6, and then we just have the x because there's no other x here. 7 times 4 is 28, and then just the x because there's no other x here. And then 7 times 2 is 14. Now again, we said we always want to look at this diagonal and see if these will add, and sure enough they do. 28 minus 6 is going to give us 22x, so that'll be our middle term. We just have the negative 12x squared for the front, and the 14 or the back. Do remember we do tend to put higher exponents first and go down by exponent. That's proper math grammar. And this is our final answer.